Hello all, welcome to Excel Academy. So today we are back with the other video on superposition theorem. So today we are supposed to start with superposition theorem. Fine. So let me have an introductory part with respect to superposition theorem. So yesterday we couldn't do it because it was a lengthier video that we had yesterday. Fine. So that is why please to try to what I can say, listen to this today. Okay, yes. So actually yesterday I had to do question paper because I told you the actual reason. So because first of all you should have an idea on how the questions are coming for an examination and how to practice for an exam, because so these subjects are all examination subjects. Okay, so examination point of view, these subjects are very much important because these subjects are not that easy or not that difficult. It's in a mid, right? So you are supposed to practice more and more. So to practice more and more, you should have an idea on how the questions are coming for exam. So for that, your question paper is the base for you. Fine. In the question paper, you are supposed to check with how many, what type of questions are coming for examinations, and you're supposed to work based on that so that you can easily crack your examination. So you have to first understand the mindset of the question paper setter, how he sets the question. So what is he going to ask next? You're supposed to have an idea. You're supposed to like predict the things now itself. So prediction helps you a lot in exams, right? Yes. So for theory exams it is nothing. If you just see the question paper and just practice things, it's fine. But for problem is supposed to put more and more effort, right? That too with respect to few of the subjects, I'm telling, not all, because DSP you can easily do it without fail. It's not that difficult. So if you understand the concepts and the procedure for one single topic, so yes, you can do all the others without fail, right? Like that. But some of the concept needs working of more and more problems, because you don't know how the question will come for examination, right? So that is why. So that in that particular what I can say, the ಅಂದ್ರೆ ಆ particular ಒಂದು ಇದರಲ್ಲಿ you are this one, what is that, circuit and control is the one. Okay, you can divide the problematic subjects into some groups like your easier subjects and difficult subjects, right? And that, so this is one of the mid subject, right? So you're supposed to practice it a lot. Okay, so that is why I just showcased you the question paper. I just showcased you how the question is coming for exam. We just saw how the questions are coming for exams, right? So we just got to know how much theory has been asked for you and how much problems are asked, right? So many people, I also told you yesterday, ಬಹಳಷ್ಟು ಜನ ನೀವು theory ಬಿಟ್ಬಿಡ್ತೀರಾ. So theory ಕೂಡ ಕೇಳ್ತಾರೆ. So have to see what is that theory that's been asked in your exam, so that you are supposed to practice on that, right? So because theory is a booster for you. So if you study theory and if you go along with the problems, at least if you ask any theory for 6 or 7 marks, you can easily gain marks, right? So don't leave theory in any of the topic in this particular subject, right? Yes. Okay, so now let's come to the superposition theorem. So according to the superposition theorem, so let me read the statement. Okay, I'm showcasing using my black arrow mark, so please do follow my black arrow mark without fail. Okay, so today we are going to learn about this introduction and the explanation of superposition theorem, along with let us do one problem. Okay, yeah, so we are going to do one problem because you have to understand things in a better manner. Okay, and so to, if you want all these things, so please do like, share and subscribe and share it to many more who are in need, and please do press the bell icon to get more and more updates on our channel. Okay, so this is why we are helping you a lot, so please do avail this facility at the most. Okay, so let's come to the superposition theorem. So in any linear bilateral network containing more than one independent source, the response in any element is equal to the algebraic sum of all the responses due to each independent sources acting independently, setting all other independent sources to 0, right? So this is what is the statement of superposition theorem. So let's learn the statement in a detailed manner. So in any linear comma bilateral network, right? So he's asking you linear comma bilateral network. So what is this? I'll tell you about this here because this is somewhat important for you even with respect to theory also, right? ಇಲ್ಲಿ theoryಗೂ ಸಂಬಂಧಪಟ್ಟಂಗೆ ಒಂದು ವಿಷಯ ಬರುತ್ತೆ, so I'll tell you that, right? Yes. So he's asking you, in any linear bilateral network, what does that mean? Linear bilateral network. So linear bilateral network means that he is explaining how the network is, right? For a superposition theorem, your network is linear and bilateral, right? The question that you get for superposition theorem, right? Whatever the question that you got for exams, yesterday we just saw the question paper, right? And that question paper, whatever the questions you have got or whatever the network you have got with respect to superposition theorem, like on the network na kottu superposition theorem solve ಮಾಡಿ ಅಂತ ಕೊಟ್ಟಿದಾರಲ್ಲ, ಆ ಏನ್ network ಇದೆ ಅವೆಲ್ಲ linear and bilateral networks, right? They're all linear and bilateral networks. You have seen, solve the to find the current Ix and the following figure using superposition theorem ಅಂತ ನಾವು questions ನೋಡಿದ್ವಿ. ಆ network ಬಂದ್ಬಿಟ್ಟು linear and bilateral network, right? Okay, so what is a linear network? So you know what's a linear network? Linear network is a network which will exhibit the constant parameters. In the sense, so what does that mean? So that is meaning that according to a linear network, so due to any change in current, due to any change in current or voltage, your resistance, inductance and capacitance of any component will remain the same, right? I can tell you as, just a minute. Yeah, I can tell you with respect to the, what I can say, the linear network is that a linear circuit is the one whose parameters are constant with the time and they do not change with voltage or current, and the circuit obeys Ohm's law. So it means that what? It means that, so for example, if your current or voltage is getting changed in a circuit, let's consider my voltage. What is my voltage? V. And what is my current? I. So let me consider that my voltage and the current is changing with respect to time. Okay. So what's that going to happen is that the components, the resistance, the inductance and the capacitance, right? Resistance, inductance and capacitance. That is, resistance is R, inductance is I and capacitance is C, right? Yes, capacitance is C. Okay, so the resistance, the inductance and the capacitance of any component will not change, okay, with respect to the change in the current and voltage with respect to time, right? That is what is a linear network. It does not change with respect to any of the changes in the voltage and the current with respect to time. Okay, yes, so it is showing a linear relationship between the voltage and the current. This is what is a linear network. So now coming on to bilateral network. So what is a bilateral network? So bilateral network is that. So what does that mean? Bilateral network is consisting of a circuit wherein, yeah, what I can say, the characteristics remain same regardless the direction of current through various components. Okay, so it means that, so characteristic of that circuit remains same regardless the direction of the current through various components, right? This is what is my bilateral network. Or I can say with respect to bilateral network, so the relationship between current and the voltage does not change in either direction of the network, right? So this is what I can say as my bilateral network, right? So if you can consider an example with respect to transmission line. So why is a transmission line a bilateral network? Is because if you supply any power from any direction, right? If you supply a power from any direction to the transmission line, the circuit property will remain constant. Okay, yes, the circuit properties will remain constant. That means that the circuit properties will not change with respect to the direction of the current. If you give the current in an east direction, if you supply power from the west direction, if you supply power from the north direction, if you supply power from the south direction also, there is no change in what? There is no change in the current. That is what is a bilateral network, right? So bilateral network in the sense the characteristics of the circuit remains the same irrespective of the direction wherein you give the current, right? Yes, so that is what is telling you, right? This is what is supposed to understand. What's a linear network? A linear network means that when you change the current or voltage, so when the current or voltage is changed with respect to time, so the parameters, that is the resistance, inductance or the capacitance of the, what I can say, the components will not change at all, irrespective of the change in current or voltage with respect to time, right? So I told that, what I can say, the linear circuit is the one whose parameters are constant with time. They don't change, right? Yes. And with respect to bilateral network, it is that when you supply current from any direction, so there is no change in what? So when you supply current from any direction, there is no change in the characteristic of the circuit, right? All the parameters. So the circuit, what I can say, the circuit properties do not change. Okay? Yes. Yeah. So you can say that the circuit properties do not change even when there is a change in the direction of voltage or current. This is what is your, what I can say, the bilateral network, right? So here, what is the linear and bilateral network combination? That means that it is a network wherein it is going to satisfy the linear property. Linear property in the sense there is no what I can say, the change in the properties, that is parameters, either the resistance, inductance or capacitance with respect to the change in voltage or current with respect to time. That is what is linear. And your bilateral is respective of the direction of the voltage or the current source to the circuit, the properties of the circuit will not change. So these both will get satisfied together in linear and bilateral network, right? In a linear and bilateral network, both the properties of linear as well as properties of bilateral network will get satisfied without fail. That is why we call it as a linear and bilateral network, right? I guess you understood things. So, containing one or more independent source. So, what is an independent source? Independent source is the independent source is the one wherein it is having a, there are many independent parameters, right? So that is what is your independent source. So just a minute, students, I'm so sorry for the distraction that's happening in the middle. Okay, yes, so sorry, just a minute. Okay. Yeah. So what is an independent source? An independent source means that, so there is a voltage or a current which is completely independent on other circuit variables, right? So here only you can see what is an independent source. I guess we have discussed with respect to the, what I can say, in the first module, right? We have discussed with respect to first module. So what are independent sources? Independent sources in the sense you have a voltage and a what I can say, the resistance. Just a minute, I'll just showcase to you. So see, we discussed with respect to independent source in the very first module. We told that this is an voltage and this is a current, right? I'm sorry, this is a resistance, right? And this is what is your R and this is what is your V. And I also told with respect to this independent sources, right? Because so the voltage, why I'll tell you, just a minute, I am sorry. Yeah, this is my independent source and this is my independent source, right? Yes. So why these are all my independent source? These are all my independent sources because the voltage of the voltage source and current of the current source. What is that? Voltage of the voltage source and current of the current source. So this is the voltage source and voltage of this particular voltage source, and this is the current. So what is this? This is the current. So current, that is I. The current of this current source is independent on, or it is completely independent on the voltage or the current existing on the other elements of the circuit. That is other elements in the sense, if you have a resistance, or here you have a resistance, right? My other element is a resistance. So he is telling that what? So he is telling that the voltage of the voltage source. So this is my voltage source, what you can see, and the current of this particular current source is completely independent on the voltage or the current of the other element which is present in the circuit, right? So for example, this is another element, say R, and if the current and the voltage of this resistance is completely independent of this particular, right? So that means that there is a this EV voltage ಏನಿದೆ ಇದರದು ವೋಲ್ಟೇಜ್ ಈ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ವೋಲ್ಟೇಜ್ ಮತ್ತೆ ಈ ಕರೆಂಟ್ ಸೋರ್ಸ್ ಕರೆಂಟ್ ಏನಾಗಿದೆ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ವೋಲ್ಟೇಜ್ ಅಥವಾ ಕರೆಂಟ್ ಮೇಲೆ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿದೆ, ಡಿಪೆಂಡೆಂಟ್ ಆಗಿಲ್ಲ. ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ನೀವು ಕರೆಂಟ್ ಅಥವಾ ವೋಲ್ಟೇಜ್ ಮೇಲೆ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿದೆ. ಸೊ ಅದು ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ವೋಲ್ಟೇಜ್ ಅಥವಾ ಕರೆಂಟ್ ಮೇಲೆ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ, ರೈಟ್? ದಿ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಇರುತ್ತೆ. ಸೊ ಇದು 4 ವೋಲ್ಟ್ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ವಿಲ್ ಕನ್ಸಿಡರ್ ದಿಸ್ as 4 ವೋಲ್ಟ್ and I'll consider this as 3 ampere current. Okay, so ನಾನು ಏನು ಮಾಡ್ತೀನಿ 3 ampere current ಅಂತ ತಗೋತೀನಿ. ಸೊ ನಾನು ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ ಇದರದ್ದು ಎಷ್ಟು ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು ಕರೆಂಟ್ ಇರುತ್ತೆ, ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ದಿಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಸೊ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕರೆಂಟ್ ಏನೋ ಫ್ಲೋ ಆಗ್ತಿರುತ್ತಲ್ಲ ಅದ್ರ ಕರೆಂಟ್ ಎಷ್ಟು ಇರುತ್ತೆ ಮತ್ತೆ ವೋಲ್ಟೇಜ್ ಎಷ್ಟು ಇರುತ್ತೆ. ಸೊ ಅದ್ರ ಮೇಲೆ ಈ 3 ಆಂಪಿಯರ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಕಂಪ್ಲೀಟ್ಲಿ ಅದ್ರ ಮೇಲೆ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ಯಾವ ಕಾರಣಕ್ಕೂ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ, ರೈಟ್? That is what is trying to tell you. Okay, yes. So now this is independent source and I'll highlight things because these are all very much important, right? More than one independent source. It is not a single independent source, right? Yes. So the response in any element, what is their response? So is giving you response. So now response andre ಏನಂತ ತಿಳ್ಕೋಬೇಕು. So your response is meaning that the, what I can say, the voltage or current or voltage across any element. So response in any element means that the current or the voltage across any element, right? So the current or voltage across any element is equal to the algebraic sum of all the current or voltage across, what I can say, all the current or voltage that is flowing across the element, right? All the individual current or what I can say the voltages that is across the element caused by what? Caused by independent sources that is acting along. So independent sources that is acting independently. So setting all other independent sources to 0. Right? We just understand this in a better manner. Just a minute, I'll highlight things. So because these things are important, so should not miss these things. So ನಾನು ಇಲ್ಲಿ theory ಬಗ್ಗೆ ಏನೋ ಹೇಳ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ದೆ. So I'll come to that now. So here see, this is independent, I'm sorry. So ನಾನು ಏನು ಹೇಳೋಕೆ ಹೊರಟೆ ಥಿಯರಿ ಬಗ್ಗೆ. ಸೊ ನೀವು ಫಸ್ಟ್ ನಾನು ಏನು ಹೇಳ್ಕೊಟ್ಟೆ, ಲೀನಿಯರ್ ಮತ್ತೆ ಬೈಲ್ಯಾಟ್ರಲ್ ನೆಟ್ವರ್ಕ್ ಬಗ್ಗೆ ಹೇಳಿದೆ, ಕರೆಕ್ಟಾ? ಐ ಜಸ್ಟ್ ಟೋಲ್ಡ್ ಯು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಲೀನಿಯರ್ ಅಂಡ್ ಬೈಲ್ಯಾಟ್ರಲ್ ನೆಟ್ವರ್ಕ್, ಆಯ್ತಾ? ಸೊ ನಾನು ಏನು ಹೇಳಿದೆ, ಸಾರಿ. ಸೊ ನಾನೇನ್ ಹೇಳಕ್ ಬಂದೆ ಅಂದ್ರೆ ಒಂದು ನೆಟ್ವರ್ಕ್ ಹೇಗಿದೆ ಅಂತ ಅವನು ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಕೊಟ್ಟಿದ್ದಾನೆ. ಅದೇ ತರ ನಿಮ್ಮ ಥಿಯರಿನಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸೊ ಒಂದು ಡಿವೈಸ್ ಬಗ್ಗೆ ನೀವು ವರ್ಕಿಂಗ್ ತಿಳ್ಕೊಳ್ಳುವಾಗ ಆ ಡಿವೈಸ್ ಅಲ್ಲಿ ಸಾವರೆನ್ ಕಾಂಪೋನೆಂಟ್ ಇರುತ್ತೆ. ಆ ಕಾಂಪೋನೆಂಟ್ ನಿಮ್ಗೆ ಏನಾಗಿರುತ್ತೆ, ಆ ಕಾಂಪೋನೆಂಟ್ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ನಿಮಗೆ ಕೊಟ್ಟಿರ್ತಾನೆ. ಈಗ ಅಲ್ಲಿ ನೆಟ್ವರ್ಕ್ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಲೀನಿಯರ್ ಮತ್ತೆ ಬೈಲ್ಯಾಟ್ರಲ್ ಅಂತ ಕೊಟ್ಟಿರೋ ಹಾಗೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಂಪೋನೆಂಟ್ಗೂ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಕೊಟ್ಟಿರ್ತಾನೆ. ಸೊ ನೀವು ಆ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಮಿಸ್ ಮಾಡೋ ಹಾಗೆ ಇಲ್ಲ. You should not write here directly network, right? This network is linear and bilateral, you should say, right? ಅದಕ್ಕೆ ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಥಿಯರಿನು ನೀಟಾಗಿ ನೀವು ಓದ್ಕೊಂಡು ಬರೀತೀರಾ. ಸೊ ಯು ಶುಡ್ ನಾಟ್ ರೈಟ್ ಇನ್ ಯುವರ್ ಓನ್ ವರ್ಡ್ಸ್, ಬಿಕಾಸ್ ಆ ಪ್ರತಿಯೊಂದು ಕಾಂಪೋನೆಂಟ್ಗೂ ನಿಮಗೆ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಅನ್ನ ಹೇಳಿರ್ತಾನೆ. ಸೊ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ನೀವು ಬರೀಲೇಬೇಕಾಗುತ್ತೆ. 2 words of description. See here, for network it is linear and bilateral. For that particular component which is present in any device, ಅದಕ್ಕೆ ಬೇರೆ ಇರಬಹುದು description, right? Yes, you're supposed to understand that and practice. Okay. So now let me come to this. So the response in any element, that is the voltage or current across the any element. So any element in the sense your element might be this resistance, inductance or capacitance. So the current or voltage across that any element is equal to the algebraic sum of all the voltage or current across what? That is individual element. That is algebraic sum of all the voltages or current that is flowing across the any individual element, right? It's flowing across any individual element, that is individual element. So due to each independent sources that is acting independently, so acting independently, so that is with all other independent sources. So you are going to replaced by the short circuit and all other independent current sources replaced by the open circuit, right? That I am going to tell you. So this is what is superposition theorem. Okay, for example, so here if you want your V, so what is your V? Your V is equal to V1 dash V dash plus V double dash plus V triple dash like that. That means that ಏನು ಇದಂದ್ರೆ ಸೊ ಇವಾಗ ಒಂದು ವೋಲ್ಟೇಜ್ ನಿಮಗೆ ಬೇಕು. ಸೊ ಒಂದು ವೋಲ್ಟೇಜ್ ಅಥವಾ ಕರೆಂಟ್ ಒಂದು ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಅದನ್ನು ಏನು ರಿಸಲ್ಟೆಂಟ್, ಸೊ ಅದು ಏನಕ್ಕೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ, ಅದು ಈಕ್ವಲ್ ಟು voltage or algebraic sum of all the voltages or current that is flowing across individual element. ಒಂದು ಇಂಡಿವಿಜುವಲ್ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಾ ಇರುವಂತಹ ವೋಲ್ಟೇಜ್ ಅಥವಾ ಕರೆಂಟ್ ಸಮ್ ಆಗಿರುತ್ತೆ. ಸೊ ನಿಮ್ಗೆ ವೋಲ್ಟೇಜ್ ಬೇಕು ಅಂತಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೇಕು ಅಂತಂದ್ರೆ ಅದ್ರ ಸಮ್ ಏನು, ಅದು ಈಕ್ವಲ್ ಟು ಏನು, ವಾಟ್ ಇಸ್ ದಟ್ ಈಕ್ವಲ್ ಟು, so that is equal to your voltages, algebraic sum of the voltages that is flowing across the element. What element? It is flowing across the individual element that is caused by separate independent sources acting alone. ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ, ಸೊ ನೀವು ಇವಾಗ ಫಸ್ಟ್ ಒಂದು ಈ ತರ ಸಮಯ ಇದು ವಿ ಡ್ಯಾಶ್ ಕಂಡುಹಿಡಿಬೇಕು ಅಂತಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಒಂದು ಸೋರ್ಸ್ ನ ಇಂಡಿಪೆಂಡೆಂಟ್ ಮಾಡಿ ಒಂದು ಸೋರ್ಸ್ ನ ನೀವು ಆಕ್ಟಿಂಗ್ ಅಲೋನ್ ಅಂತ ಮಾಡಿ ಮಿಕ್ಕಿದೆಲ್ಲ ಸೋರ್ಸಸ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಅಥವಾ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಬೇಕು. ಸೊ ಅದು ನಿಮ್ಮ ಸೂಪರ್ ಪೊಸಿಷನ್ ಥಿಯರಮ್ ಅಂತ ಅಂದ್ರೆ. ಇವಾಗ ನಾನು ಇದು ಡೀಟೇಲ್ ಆಗಿ ಇಲ್ಲಿ ಹೇಳ್ತೀನಿ. ಸೊ ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ಸೊ ನಮ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ, ಒಂದು ವೋಲ್ಟೇಜ್ ಅಥವಾ ಕರೆಂಟ್ ನಿಮ್ಮ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ ಏನು ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಅದು ಈಕ್ವಲ್ ಟು ಏನು, ಸೊ algebraic sum of all the voltages or elements that has been what, that has been flowing, algebraic sum of all the voltages or current that has been flowing in the, what I can say, flowing in the individual element. Okay, so andre eno, so algebraic sum of all the currents or voltages that is flowing across the individual element. ಆ individual element ಅಲ್ಲಿ ಏನ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ವೋಲ್ಟೇಜ್ ಅಥವಾ ಕರೆಂಟ್ ಅದರದ್ದು ಸಮೇಷನ್ ಆಯ್ತಾ, ಅದರದ್ದು ಸಮೇಷನ್. ಅದಾದ್ಮೇಲೆ ಏನು ಟೆಲ್ಲಿಂಗ್ ದಟ್, ಸೊ ಡ್ಯೂ ಟು ಈಚ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಸೋರ್ಸಸ್ ದಟ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ಇಂಡಿಪೆಂಡೆಂಟ್ಲಿ. ಸಿ ಹಿಯರ್, ಡ್ಯೂ ಟು ಈಚ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಸೋರ್ಸಸ್ ಆಕ್ಟಿಂಗ್ ಇಂಡಿಪೆಂಡೆಂಟ್ಲಿ. ಸೊ ನಿಮ್ಮ ಪ್ರತಿಯೊಂದು ವೋಲ್ಟೇಜ್ಗೂ ನೀವು ಒಂದೊಂದು ಸೋರ್ಸ್ ಅನ್ನ ಇಂಡಿಪೆಂಡೆಂಟ್ ಮಾಡಿಬಿಟ್ಟು ಮಿಕ್ಕಿದ್ದನ್ನೆಲ್ಲಾನು ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ or ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್. ದಟ್ ಇಸ್ ವಾಟ್ ಯು ಆರ್ ಸಪೋಸ್ ಟು ಡೂ, ರೈಟ್? Okay, so that is what is the superposition theorem. So you'll understand this in a better manner. See, ನಿಮ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಹೇಳಿದಾನೆ, ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಅಂತ ಆಗಿದ್ರೆ, so it is, if it is a voltage source, it is replaced by its internal impedance. So internal impedance ಗೆ replace ಆಗುತ್ತೆ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಆಗಿದ್ರೆ ಅಥವಾ or a short circuit. So if it is a current source, it is replaced by an open circuit. ಇದು ಯಾಕೆ ಕೊಟ್ಟಿದ್ದಾನೆ ಅಂತಂದ್ರೆ ನಾನೇನ್ ಹೇಳಿದೆ, ಈಗ ನಾವು ವಿ ಡ್ಯಾಶ್ ಕಂಡುಹಿಡಿಬೇಕು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಒಂದು ಸೋರ್ಸ್ ಅನ್ನ ನೀವು ಆಕ್ಟಿಂಗ್ ಅಲೋನ್ ಅಂತ ಇಟ್ಕೊಂಡು ಮಿಕ್ಕಿದನ್ನೆಲ್ಲ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಅಥವಾ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡ್ಬೇಕು ಅಂತ ಹೇಳ್ದೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸೊ ನೀವು ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಅಥವಾ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಸೊ ಅದು ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಇದ್ದಾಗ ಅಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಮತ್ತೆ ಕರೆಂಟ್ ಸೋರ್ಸ್ ಎರಡು ಇರುತ್ತೆ. ಸೊ ಇಫ್ ಯು ಆರ್ ಕೀಪಿಂಗ್ ಎನಿ ಒನ್ ಸೋರ್ಸ್ ಆಸ್ ಆಕ್ಟಿಂಗ್ ಅಲೋನ್, if you have a 16 volt source, let me consider. So if you keep a 16 volt source acting alone, then what's that going to happen? There are two other sources which are voltage or current. So ಅದರಲ್ಲಿ ನೀವು ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಆಗಿದ್ರೆ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಬೇಕು, ಕರೆಂಟ್ ಸೋರ್ಸ್ ಆಗಿದ್ರೆ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಇದನ್ನ ಹೇಳಿರೋದು, ರೈಟ್? ಇಲ್ಲಿ ನೋಡಿ, ಆಲ್ ದ ಅದರ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಸೋರ್ಸಸ್ ಟು what I can say the short circuit or open circuit ಗೆ ರೀಪ್ಲೇಸ್ ಮಾಡಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ ಅಥವಾ ಝೀರೋ ಅಂತ ಹೇಳಿದ್ದಾರೆ, ಎರಡು ಒಂದೇನೆ. ಸೊ ಅದ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ವೋಲ್ಟೇಜ್ ಸರ್ಕ್ಯೂಟ್ ಅಥವಾ ಕರೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ ಇದೆಯಾ ನೋಡ್ಕೊಂಡು ವೋಲ್ಟೇಜ್ ಸರ್ಕ್ಯೂಟ್ ಗೆ ಏನ್ ಸೋರ್ಸಿಗೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಕರೆಂಟ್ ಸೋರ್ಸ್ ಗೆ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಓಕೆ, ಸೊ ಹಿಯರ್ಸ್ ದಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. Consider an electrical network as shown in figure. So this electrical network is what? A linear and a bilateral network. I am showcasing in black color. Fine. This is a linear and a bilateral network. Okay. Yes. So now let I2 be the current flowing through Z2. So ಏನಾಗ್ತಾ ಇದೆ, ಯಾವುದು ಕರೆಂಟು, ಇಲ್ಲಿ I2 ಕಾಣಿಸ್ತಿದ್ಯಾ? I am highlighting in black color. So this I2 is flowing through Z2 and where both the sources E and I are present in the circuit. ನಮ್ಮ ಹತ್ರ E ಇದೆ. E ಅಂದ್ರೇನು? ವೋಲ್ಟೇಜ್. So this is RMS, right? And here it is I. ಆಯ್ತಾ? So now consider the source E only, replacing the current source by an open circuit. Okay. So now when we are considering that the source E is acting alone. So source E is acting alone anta heli ನಾವು ಬರಿ ಇದನ್ನ ಇಟ್ಕೊಂಡು ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಈ ಐ ಅನ್ನ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಯು ನೋ ದಟ್ ಫಾರ್ ಅ ಕರೆಂಟ್ ಸೋರ್ಸ್ ಇಟ್ ಇಸ್ ರೀಪ್ಲೇಸ್ಡ್ ಬೈ ಅನ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್. ಇಲ್ಲಿ ಇದೆ ಕಾಣಿಸ್ತಿದೆಯಾ? ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ ಅ ಕರೆಂಟ್ ಸೋರ್ಸ್ ಇಟ್ ಇಸ್ ರೀಪ್ಲೇಸ್ಡ್ ಬೈ ಅನ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್. ಸೊ ನಾವು ಅದನ್ನ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಬೈ ಕೀಪಿಂಗ್ ದಿಸ್ ವೋಲ್ಟೇಜ್ ಆಸ್ ಇಟ್ ಇಸ್. ಸೊ ಫಾರ್ this what is that going to happen is that I'll just showcase to you just a minute. I guess half the figure bandide nimge innu ಕೆಳಗಡೆ there are some things I'll just so if you keep only this you bari idanna itkondre ಏನಾಗುತ್ತೆ so bari idanna itkondre ಏನಾಗುತ್ತೆ so you will be having a current say I2 dash. Okay, yes, so I2 dash, so you'll get a current I2 dash. so ನಿಮಗೆ source E ಮತ್ತೆ I ಎರಡು ಇದ್ದಾಗ like if you are having the voltage sources, like if you are having the voltage source E and current I, you will be having a current of I2, right? Now when you want to find the I2 dash andre ಏನು? So the very first current, right? I2 dash. So I2 dash ನಿಮಗೆ ಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? So ನೀವು voltage source ಅನ್ನ ನೀವು ಹಾಗೆ ಇಟ್ಟುಕೊಂಡು current source ನ open circuit ಮಾಡಬೇಕು. So this is what you are supposed to do, right? So next, let just a minute, I'll just check with the other diagram. Okay, the next is